Hi, today we're going to talk about derivative. In its simplest term, it is the slope of a tangent line. So the illustration here, you can see there's this given function f of x, okay? And then there's this line, which is the tangent line. It's a tangent line because it intersects the given function at one point, okay? So this tangent line, its slope is the derivative, okay, of the given function. All right, so let's go ahead and see the mechanics of the power rule of differentiation. All right, so let's say we're asked to find the derivative of the given function using the power rule. So this is one basic derivative rule, okay? And later on, I'm going to show you the shortcut using the power rule. All right, so let's suppose we have f of x equals, we're going to start with the simplest function, say constant 3, okay? So whenever you have a function that's equal to this constant, so this is a constant function. Now, the derivative f prime of x is just going to be 0, okay? Now, if you're going to, if you're going to graph this constant function, it's really a horizontal line, okay? Horizontal line through 3 on the y-axis. So this is your x-axis. And the graph of y equals 3 or f of x equals 3 is a horizontal line. Now, you talk about the slope of this horizontal line, it's going to be 0, okay? So that's one way to remember that the slope of a tangent line to this constant function is 0, or the derivative of any constant is going to be 0, okay? So one more, let's say you have f of x is equal to 10, okay? 10 is a constant, its derivative is 0, okay? Let's say you have this given function x, okay, 6x. Now we have a variable here, which is x. Now we know that x means x to the first power, okay? So the power rule says if we have nx, okay, to the m, its derivative using power rule is, okay, so what we do is multiply this exponent m to n times that base x raised to m minus 1, okay? So that's the power rule right there. Now we have a constant 6 or coefficient 6 over here. But we also have a variable x. So what we do, because this is just a constant, and we know that the exponent of x is 1, using this power rule, so we can multiply that 1 and 6. Okay, so 1 times 6, and then times that variable x raised to 1, okay? According to the rule, you take away 1, okay? So now you have 6x to the 0. Now, number raised to 0 is 1, so it's just going to be 6. All right. In short, if you see a coefficient, say 6, in a variable plane x, its derivative is just that going to be equal to that coefficient 6, okay? Say another example, okay? Say f of x is equal to 12x. So its derivative is simply this coefficient 12. Again, because it's just 1 times 12 is 12, and then x raised to 1 minus 1, which is 0. So this is going to equal to 1 times 12. It's just going to be 12, okay? So whenever you see a given function that's equal to some number, okay, say 7, and then variable plane x, okay, right away, you can use the power rule by remembering that it's just going to equal to that coefficient 7. Right, what happened when we raise that x, say 5x squared? Okay. Now, its derivative f prime of x is 2 times 5 is 10, x raised now to what? 2 minus 1. So that is 10x, okay? Okay, one more. Let's say you have f of x is equal to negative 4x cubed. So what is the derivative? F prime of x is 3 times negative 4, negative 12. X now raised to 3 minus 1 is 2. Okay, so let's go ahead and increase the difficulty of our examples. What happened when the variables, say variable x is downstairs? So what do you do? All right, so what we can do here is use that property of exponent. You can move this you can move this variable x to the top. Okay, so you can rename that first, because the power rule, okay, I want to emphasize this, the power rule suggests, okay, so if you have again n x to the m, okay, so this variable x has to be numerator before we can apply this power rule, before we can multiply this mn, and then that same base x now raised to m minus 1. So that variable x has to be a numerator. So what we do is move this denominator x on top, okay? Now the property of exponent says that whenever you move a variable, you have to switch the sign of that variable x. So that one, which was positive, is now a negative 1. Right? So when you move this x on top, you have this 1 left underneath. It's just 1 anyway, so it's still going to be that x to the negative 1. All right, now you can start applying the power rule. So this negative 1 times this understood 1 as coefficient is equal to negative 1 x to the negative 2, because you're going to take away 1 from that negative 1. So negative 1 minus 1 is going to be negative 2. Now your final derivative, okay, is going to be expressed using positive exponents. So what we can do is we can move this x to the negative 2 downstairs, and that makes that negative 2 positive. Okay. Okay, later I'm going to give you some shortcut, okay, using this power rule. Okay, let's see. Let's say f of x is equal to 1 over x squared. How do we rename this? Again, we can move this up. That switch the sign to negative 2. Since your variable x is now a numerator, we can start using the power rule. Okay, so negative 2 times 1 is negative 2 variable x raised to negative 2 minus 1. That equals negative 2 x to the negative 3. And then we can move this downstairs. Okay, so our final expression is going to equal what? Negative 2. Negative 2 will stay on top. And then the x to the negative 2, sorry, negative 3, sorry, is now a positive 3. Let's do one more example. Say you have 1 over, let's say it's a 4, okay? So let's say this is your f of x. Let's say this is a 4, and you have like x to the 5th. So now again, we can rename this, all right, by moving this x to the 5th on top. So now it's x to the negative 5. And now begin your power rule. So that's negative 5 times 4 is negative 20. X to the negative 5 minus 1. So, oh, I'm sorry, this is not negative. This is just f prime, okay? So f prime of x is equal to negative 20, x to the negative 6. Okay, better still, we can express this using positive exponent. So negative 20 will stay on top. And then this x to the negative 6 has to go down. So that's now x to the positive 6. All right. What about combinations of constants and some variables? Okay, so let's say you have negative 6x cubed plus 4x squared minus 3x plus 7. So you have to use the power rule here like 4 times because you have 4 terms. So your f prime of x is going to be negative 18, right? So 3 times negative 6 is negative 18. X raised to 3 minus 1 equal to 2 plus 2 times 4 is 8. X raised to 2 minus 1 is 1. Okay. Minus. All right. So this is just 1. So whenever you see 3 plain x, 3 times plain x is just equal to that negative 3. Again, this is a constant. The derivative of constant is 0. This is it. This is our derivative, right? Okay, I promise you there's a shortcut. Okay, when we get to the square root, let's say I have a shortcut for you. So it's a trick, hack, or shortcut. Whenever you see a square root of x, all right, you need to memorize this because you're gonna see this a lot in your calculus class. So whenever you see a square root of x, its derivative, you have to memorize this. It will help you a lot, make your life easier. It's always going to be 1 over 2 square root of x. All right, memorize this. The derivative of square root of x is 1 over 2 square root of x. This will, again, make your life easier. Okay, if you memorize the square root of x derivative, 1 over 2 square root of x. If you want to see how you get that 1 over 2 square root of x, okay, I'll show you. Let's say you have square root of x here. Now we know that a radical says square root of x is equivalent to x raised to the exponent of that variable x, which is 1, over this index here, which is 2. So square root of x is equivalent to x to the 1/2. If you get the derivative using the power rule, so you multiply that 1/2 times 1, or you can pull that 1/2 out front, that's 1/2 x, okay, 1/2 minus 1, okay? But 1 can be in the form of what? 2 over 2, 3 over 3, 4 over 4, 5 over 5. In this case, I'm going to use the 1 equals 2 over 2, okay? So 1/2 x to the 1/2 minus 1, or minus this 2 over 2, which is 1/2 x raised to what? Negative 1/2. Okay, again, having this negative exponent, let's express that to something with a positive exponent. So that's 1/2. If I'm going to move this x to the 1/2 negative downstairs, okay, that negative 1/2 is going to turn into positive. All right, so now we have what? 1 over 2, and you can write this x to the 1/2 back to its radical form. Okay, so as you can see, this is a very tedious process of finding the derivative of square root of x. But again, whenever you see that, just memorize, okay? The derivative of square root of x is 1 over 2 square root of x. Now, let's say you have some number 3 in front of the square root of x. What is the derivative using the shortcut? Okay, this is just constant right here. So what you do is bring this down and then get the derivative of that square root of x, which is what? 1 over 2 square root of x. So you can just multiply the 3 times 1, which is 3 over 2 square root of x. And lastly, okay, just to make sure you get this number 13, let's say it's a 5 square root of x. What is the derivative? The derivative is 5, okay, over 2 square root of x. Okay, I will be posting more derivative tutorials. So this is just the first part. And I will show you some more tricks, hacks, or shortcut in finding the derivatives of a more complicated function. Okay, so thanks for watching, and I'll see you again next time.